So let's look at an example of a hypothesis test for proportions. The only difference we're going to have for proportions is that our two hypotheses will have a p in them instead of a mu, and we're going to use a different test statistic. All right, so let's keep in mind that we're going to use a p, and let's take a look at this example. Test the claim that the proportion of people who own cats is larger than 60% at the 0.005 significance level. Now, the 0.005 significance level is our alpha, and here's our proportion expressed as a percentage, 60%. It's a 0.6 as a proportion. Now, this is asking us to claim or test the claim that that proportion is larger than 60%. So our alternate will be larger than 60 or greater than 0.6. Let's find P greater than 0.6. If we go down through here, well, that's a less than, so that's not it for our alternate. P greater than 0.6. And of course, the null is going to be its opposite. So P greater than 0.6 is that one right there. That is, since our alternate is a greater than, it's pointing to the right. It's a right-tailed test. Okay, so our next step would be to find our test statistic. And we're going to do that. Notice it asks for the p-value, though. So we're going to have to find our test statistic on paper. And then we'll have to look up the p-value from that test statistic. We have 100 people in our sample, and 69% own cats. So that's our p-hat, 69%. So when we use our formula for the test statistic, let's go over here. We need p-hat first. So that's the 69% as a decimal, minus the p that we had. And let me go back to it for a second. Our p was 0.6. And then let's keep in mind our sample is 100. All right, so 0.6 is our p, divided by, now in the bottom, we're going to have square root of p times 1 minus p over n. All right, so p for us was 0.6, 1 minus p, and then over n, and n was 100. All right, now what you really need to be careful about here is to do this very slowly so you don't make silly mistakes in the calculator. So 0.69 minus 0.6 on the top is 0.09. I'm going to do the bottom in steps for you. All right, so oops, except I can't type. Square root. All right, I'm going to do the 1 minus 0.6 first. So what I've really got here is 0.6 times, and 1 minus 0.6 is 0.4 over 100. All right, and the next thing I'll do, leaving the rest of it the same, is I'm going to do what's in those parentheses. So I'm going to do, in my calculator, 0.6 times 0.4 divided by 100. That gives me 0.0024. Now, I'll go ahead and I'll take the square root of 0.0024. And that gives me 0.0489898. Now be careful, don't round off too early or you're going to get your p-value significantly off and get it wrong in your homework. Now I'll do this final division. At this point, I can round off a little bit, and this is going to be 1.837. Okay. Now that we've got that for Z, we're going to go ahead and look it up in Excel. Now let's remember that this was a right-tailed test. Remember from the problem that we had a greater than for our alternate, so it's right-tailed. And with a right-tailed test, we always subtract what we get out of Excel from 1 in order to get our p-value. So we'll have 1 minus whatever I get when I put 1.837 in Excel. So let's do that. Equal norm.s.dist 1.897. Oh, now it's hiding it from me, isn't it? 837. 837, true. And that gives me 0.9669. Okay, so 0.9669. Now let's go ahead and do that subtraction. 1 minus 0.9669. We get 0.0331. Now, let's compare that to the alpha we started with. Remember, if this is smaller than alpha, we will reject the null hypothesis. If it is bigger than alpha, however, we will be unable to reject the null hypothesis. So let's look back and see what alpha was. Alpha was 0.005. So our 0.03 is bigger than alpha, which means that we failed to reject the null hypothesis. Now, let me put that p-value in here where it's calling for it, 0.0331. And it says to 2 decimal places, so that's 0.03. And we failed to reject the null hypothesis. And that does it for us.